All right, next section is factoring the following quadratics. So we're going from standard to factored form. The first step is always, for any of these, factor out the greatest common factor if it exists, right? And that's like your A when factored form looks like this. And these can be pluses or minuses. So for number one, for part A, we can divide both of these numbers by 3. And we can also divide both of these numbers by x because they have at least one x in them. So the way we're going to factor this one is by bringing out the common factor, 3x. When you divide this by 3, there's no number left because it's a 1. And when you divide x squared by x, we're just left with an x. 21 divided by 3 is 7. The x cancels each other out, so we're just left with 7. We know we're finished when there's no more x squareds, right? If we're able to do it, there will be no more x squareds in the answer. All right, this one has no greatest common factor, so we get to move on to the next step, which is if a is equal to 1, right, we write out the pattern, which we'll actually use these as pluses. X and x here. And then fill this in with the numbers that multiply to C and add to B. Multiply to C and add to B. And this is the thing where if you can look at this and say it's 3 and 4, great. Do it. And anytime you have your own method and it works, I'm cool, right? But if you like a more systematic approach, if you like to know that you'll have the same thing every single time, what we do is write out the factors of 12. So write out all the ways you can think to multiply and get 12. And then see when you add them up, what do you get? And then we'll pick the one that adds to this middle term. So you can fill out 3 and 4. So let's do it again. Here, our a is 1, so there's no coefficient on the x squared term. So I'm going to write out my pattern. I'm going to say, what are the ways to get to positive 15? I can do 1 times 15. I can do 3 times 5. 3 times 5 adds to positive 8, which is looking pretty good, but we actually want to care about the negatives. Because we're trying to add to negative 8, we'd actually want this to be negative 5 and negative 3. That still multiplies to positive 15. So we can write in negative 5 and negative 3. And of course, we can always check our work by saying negative 5 times negative 3 is positive 15. Perfect. And negative 3 plus negative 5 is negative 8. Great. Let's do it again. There's no a term, or our a term is 1, rather. So I'm going to write in this pattern. I'm going to write all the ways we can multiply to 24. Then I'm going to realize I actually want negative 24. So I need to make one of these negative in each of the pairs. I'm going to pick the smaller ones because I know that my thing is eventually going to add to a positive number. If you accidentally pick the wrong ones, and you can add to negative 5, just flip the signs, and then that'll be positive 5. These two, when you add them, equals positive 5. So my numbers must have been negative 3 and 8. Again, if we had accidentally been like, oh, this multiplies to negative 24 and we get negative 5, just say, oh, we should switch those. We shouldn't have positive 3 and negative 8. We should have negative 3 and positive 8 if the number is right but the sign is wrong. All right, we're starting to get into ones that are wackier. Remember our actual first step, which is let's factor out the greatest common factor if we can. So for part E, I noticed that all of these can divide by 2. The first thing I'm going to do is factor out a 2 by dividing all of these terms by 2 and then writing out front, hey, this is secretly all multiplied by 2 this entire time. Now, when we look at this part, it's just this, right? We've got one of our old problems again. We can rewrite this as x plus blank and x plus blank. We do have to write the 2 out front to remind ourselves that at the end, that we are multiplying this by 2. But now I'm writing out the multiples of 20. Seeing which ones add to 9 and putting them in my answer. So again, the answer here is all of this. It's got the 2 out front as well. All right, for part F and G, this is the AC Xbox method, right? Because I can't divide all of these numbers by 2. There is no greatest common factor. So now we say, if A is not 1, what do? This is the Xbox method. This is when I create an X puzzle where the bottom is 15 and I'm adding to 15, and the top is 2 times 18, and I'm trying to multiply to 36. So first, we're going to do an X puzzle where the top is A times C and the bottom is B. I'm going to write out my factors of 36. So 1 times 36, 2 times 18, 3 times 12. Spoilers, that's the one. 4 times 9, 5 times nothing, 6 times 6, and we're going to start repeating ourselves. These, when added, are 15. So we're going to want to put 3 and 12 here. So this will be like our, like there's a number here, and there's a number here. Great. The next thing we do is make a box for the Xbox, right? And our box we'll rewrite the first term, we'll rewrite the second term, and then we'll use these two things, these two numbers that we found in the Xbox puzzle, to split up our B term. So let's make our box. I'm going to rewrite 2x squared. I'm going to rewrite the first term in the first box. I'm going to rewrite 18, rewrite the last term in the last box. And then instead of writing 15x, I'll write 3x and 12x. Now we want to solve the box. We want to factor. So I take this column, and I say both 2 and 12 are divisible by 2, and they both have an x in it. When I take this, 2 and 3 are co-prime. They don't have any common factors except for 1, but they do both have an x. Here, 3 and 18 can both be divided by positive 3. And 12 and 18 both have 6 as a factor. So overall, I get to factor to x plus 6 to x plus 3. And I got that because I read it off the side of my box. Let's do it again. For this one, there's no common factor, right? We can't divide 25 by 3. So I'm going to do my Xbox puzzle. 25 goes in the bottom. 3 times 28. Clear. 3 times 28 is 84. I'm going to list the factors of 84. And again, the way I do this when I'm like, oh my God, what is happening? You do 1 and see if it works. Then you do 2 and see if it works. 2 is going to work, right? You do 3 and see if it works. It does. So I'm actually using my calculator. So 84 divided by 3 is 28. That's what we just did to find 84. Y'all, that's embarrassing. Where's my mouse? $28. Does 4 work? Probably. Yes, it's 21. Does 5 work? No. Does 6 work? Yes. And it's 14. Does 7 work? Yes. 84 divided by 7 is 12. Does 8 work? No. Does 9 work? No. Does 10 work? No. 11 doesn't work. And 12 does work, but we've already got it, so we're done. And now we need to see which of these adds to 25. It's 4 and 21. We probably could have stopped, but that's fine. So our puzzle says it's 4 and 21. Now we do our box. It's this. We rewrite the first and last terms from our original equation, and then we use these to split up the 25. 3 and 4 have nothing in common, so this is just an x. These have a 3 in common, and they both have x's. These both have a 7 in common. 21 divided by 7 is 3. 28 divided by 7 is 4. And then these both have a 4 in common. So our final answer is x plus 7, 3x plus 4. Great. And then the other version of this, oh, the cats are fighting. Hey, Cooper. Cooper, stop it. Sorry, y'all. When we've got a pattern that looks like this, we've got an x squared minus something that looks like something squared. This is called the difference of two squares. And we immediately just get to say it's x plus and x minus whatever the square root of 49 is. So again, if I have x squared minus 16, I just get to say, oh, that's x plus 4x minus 4. Right, here's another example. If I have x squared minus, I don't know, 144, I get to say that's x plus 12, x minus 12. All of these other methods will work as well, but this is like such a common pattern that we really just want to know. All right, that's section 3.